Hello again to those that have joined from the previous video, and to all others, welcome. This is Your IT Explained, and this video is a demonstration in a lab environment of the route map technologies from the Cisco ENARSI exam. So what we have in front of us is a GNS3 lab that I'm hosting on my home computer, and I'm just running intra-area OSPF routes between these 5 devices and then an external internet connection. Feel free to pause the video if you need to digest exactly what is configured here. Otherwise, we'll get started straight away with the route map configuration. So first, what we're going to try and achieve here is we want to filter telnet traffic from router 9 destined for this interface over here, so on router 5 basically, on router 5. We want to filter it so that it only takes a particular path. So I want it so that, or actually it prefers a particular path. So I want the telnet traffic that comes through here to go this way through router 4. And right now it actually has the option to go via router 2, 3 or 4. So let's just verify what that looks like on router 1 at the moment. So you can right click and go console or double click on it, and then I'll just expand out this window so you can see it a little bit easier. Right, so I'm on router 1, which is that device in the middle. So just to show you what's running, I'm going to do a show IP route, and we'll see we've actually got a fair bit going on here. There's many routes, including up the top we have a default route coming through OSPF, and it's an external OSPF type 2 route, and it has 3 paths, as we can see here, 14, 13 and 12. So the way that the addressing works is 12, so sorry, we'll say the second octet matches the OSPF area number, the third octet it matches the router numbers, so router 1 to router 2 is 12, 1 to 3, 13, and then the last octet matches the individual router number. So this interface there would be .2, that would be .2, that's .5, .5, .5, .5, etc. Okay, so now that we understand that, we can see we've got these connected, directly connected connections, obviously all going through router 1, but then we have that default route which has been distributed through OSPF, and we also have these two here. So it definitely knows about the 192.168.1/24 network, and it's got those 3 paths to reach it. So it goes out any of these 3 paths. So right now, if router 9 telnets through, it will basically choose whatever the best path is available at that time, because they've all got the same metric, the same admin distance and the same metric. And I'll just open up a connection on router 9 so you can see what its route table looks like before we test that out. So show IP route, and now we can see on router 9 it's also learning that same default route, but we go down to the bottom and it's also learning the OSPF external type 2 route to this is going straight to that next hop address. So that .1 indicating router 1 between router 9 and 1 being there. So it obviously just sends everything there as its only real connection, and then once router 1 receives it, it sends it there, there or there, whichever way it wants to at the time. So we want to manipulate it so that the telnet traffic going through is going to only take this path down here to go to there. Now, is that achievable in a route map? It certainly is. And let's have a look at how we configure that. So make sure we're on the right device. I'm on router 1 now. This is where you configure the route map. So noting we're looking for this traffic, we're configuring it on router 1. So I'll just quickly show that we don't have any route maps running. So show route map returns nothing, and if I do show access lists, nothing. Excellent. So we're just going to go to configure terminal, and now I'm going to specify or define our route map. So I'm going to call it RM1, and I can leave this blank and press enter, and that is going to just, because I didn't specify anything here, it's going to use the defaults of permit and the default sequence number of 10. If you want to change that, you have to specify it. We'll verify that in a moment's time. But now, we remember we have to set the match command and the set command. So, or you don't have to set either of those either. So I could just press exit now. And that's done. So what's actually going to happen if I do show, if I can spell route, if I can spell, we can see it's created route map RM1. As I said, default behavior is permit, default sequence is 10, default match and set is, so it's left blank, but the actual behavior of this is, because we didn't specify anything in this match clause, the default behavior of the match clause is to match all prefixes. So right now, this will match every bit of traffic that goes through, but we haven't associated this route map with anything, so it's not actually going to route any traffic as of yet. So just so you have to understand that this is like the default behavior, because it's potentially going to be something that you're going to be tested on when it comes to the exam. Just that deeper level understanding of route maps. So I'll go back into the route map, so route map RM1, and I'll make sure we're going to the right place, permit 10, and I'm going to match IP address, and you can see here these are the options. I'm going to use an extended IP access list, and to use the extended range, it's actually within, so an extended access list is between the numbers 100 and 199 are the are extended access list numbers as well. So this is a little bit confusing because there is a slight difference between an IP access list and an access list. They're defined differently and they behave a little bit differently, but you can just use an access list number here. So if I put in match IP address 199, we'll come back to that in a second when I define it. But what behavior do we want to do with this traffic, this telnet traffic? Remember, we wanted to set it so that it uses this as the next hop. So to specify that, you do set IP next hop and then the actual address. And that's it. So that's all well and good. We've defined that part of the route map, but remember we also need to now define that access list. So what I was getting at before is you can do access list and define it this way. And you can see here 100 to 199 is the one of the extended ranges, and 1 to 99 is standard. Or you do IP access list, right? And it's actually different. It's a little bit different. So here, now you type in standard or extended. So if I were to type in extended, you can then see it now refers to those numbers correctly. So just try not to get too confused on it. And I'm using just a regular access list definition here. I'm using that same number as before. And I am going to permit this traffic. And now you can start to get a little bit more nitty-gritty into the details. So we want to filter for telnet traffic from this network. So it doesn't specifically have to be this host. I'm just going to say from that network. So for that, I'm going to say TCP, because telnet is TCP traffic. Now you specify a source address. So I'm going to use that network of 10.10.91.0. Now you have to specify the wildcard mask for that. So I'm going to specify it as the /24. And now you choose the destination. Now I'm actually not going to specify this as a destination. I'm just going to say any traffic from here telnet traffic from here going through this device to anywhere I want filtered to this next hop. Because at the moment, this is the only device that is configured to accept telnet anyway. So for me, this works. I'm just going to say any. Now you have to specify EQ. We'll say equals, and now you can put in the port number 23, or you can type in telnet, and that's it. So press enter, and now it's defined. I'll show you what this looks like with the show. First we'll do show route map. Actually no, I'll show you the access list first. So show access lists. We can see we have this extended IP access list 199 defined. Because I didn't specify any sequence, use sequence 10. It's permitting TCP from this address to any address equaling telnet. And now we'll have a look at the route map. And we'll see that route map RM1, as we looked before, is still permitting sequence 10. It's matching that access list that we've just created. And if it matches an IP range in that access list and the type of traffic is telnet, then it will perform the set clause. So it will then set the next hop address to this. Okay? If it does not match this, then it will move on to the next sequence in the route map. That's how route maps behave. Alright. So we've defined all that. The issue now is we haven't done that final step. We haven't associated the route map with anything. We've defined the route map, but it's not associated with an interface or a routing protocol. So what I'm going to do is I'm actually going to associate it with this ingress interface. You might think to put it on this egress interface, but that would be incorrect because we're going through here, and by the time the router receives the traffic and it has to decide what to do with it to process it, it might decide, I'm going to look at my routing table, and then I'm going to look at what the best path is. Okay, I see the best path is this way, and send it there. And when it hits this interface, there is no route map, so it just goes because you've put it here. It needs to check it as it enters the device before it looks at anything else at the routing table on the ingress interface. And so for router 1, this interface is, you can see it's a serial link. So this is serial 2/0. And that's where I'm going to put the route map. So I'm going to go back into configure terminal and interface 2/0. Now to associate the route map, you type in IP, policy, route map, and then the name of your route map. Now you don't specify in or out here. It's not like associating an ACL or an access group. You can only specify the name. So you press question mark, there is no option to say in or out. So it's just in any direction through that interface. And now we are done. So we've created the route map, we have created the access list, and we have associated the route map. So let's have a look. I'm going to again run the show route map. So we can see it's all as it was before, and now pay attention to this bottom line here. Let me move it more centrally. Policy routing matches, 0 packets and 0 bytes. Okay, now I'm going to go to router 9 and I'm going to telnet to this address. Let's see what happens. So on router 9, I'm going to telnet to 192.168.1.5, and we can see it's prompting for a username. Excellent. I'll put in the username and the password, and I'm in router 5. So telnet success. And now I'm back into router 9. If I go to router 1 and I refresh this command, show route map, we can now see we have matched on this route map 40 packets. So it was evaluated. Alright, so it has successfully evaluated this sequence for 40 packets, and therefore we assume it's used this set clause of setting it to the next hop IP of this address. Now, this is where you have to really understand the proper use of route maps. This is kind of poor practice if you're trying to filter it so that you only want this next hop, and if this isn't available, don't use these. That's not really the purpose of a route map. That's where you'd go into access lists and down that path. So the issue is if this next hop IP address is not available, so if this is down or this is down, it's just not available, what will happen is it will run through this sequence, it will match, it will set the next hop address to that address even though it's not available. It will try to send it there, but it will realize that that next hop is not available. So what it does is it reverts to default routing behavior. It looks up the routing table and then sends it out whatever the next best path is. So if this isn't available, it still will route and still will go via one of its other destinations. So let's actually test that to prove it. So if I go into Configure Terminal, I go into the relevant interface that I want to turn off. So I'm in router 1 and I want to shut down this interface, which is from R1 Ethernet 0/2. So I'm going to interface E0/2 and I'm going to shut it down. Just wait a moment and I will go back to back out of the configure terminal and let's just do a show IP route. Now if we look here at our default route and our route to 192.168.1/0 network, we can see we now only have 2 paths. We no longer have the 14 path because that interface is down. So it's definitely not available. It's not possible to go down this direction anymore. That interface is down. I know it looks green there, but we can't route that in that direction, right? So noting we haven't changed the route map, and we can still do show route map, and it's still got that next hop set. And notice it's got 40 packets that have been evaluated. If I go to router 9 and I telnet through again, success, it's reached the device. Okay, let me just exit out. Yep. Go back to router 1, refresh the route map, and it has evaluated it again. So it did go through here, it did match that IP address, it set the next hop address to that despite it being unavailable, or it tried to, and because it's not available, it does default router behavior, so it looks up that route in the routing table and sends it to either of these 2 destinations. So it's important you understand how these route maps behave with all the complex things that you could manipulate and change. There's many different things that a route map can do, and I can't cover all of them in one video or you'll be here all day trying to learn about route maps. But that covers off on some of the basics. But let's say that for argument's sake you really want to set it so that it only uses this as the next hop, and if it then isn't available, tries to reach these destinations, it drops the packets or it doesn't route. Is that possible with route maps? Yes, it is possible, and I'm going to show you how we can do that. Alright, so what we're actually going to do is we're going to make use of something else you need to understand with route maps, and that's tagging the traffic. So we're going to add another set clause here. Not only are we going to set the next hop address, we're also going to tag the traffic to a particular number. We're just going to choose a number to tag it with, and then on these 2 interfaces, the other 2 choices that are available, we're going to match that tag and send the traffic to null 0. Okay, so we're going to match the tag that we set in this sequence, and then we're going to send the traffic to null 0. Effectively meaning if it doesn't go here and it's trying to send it out one of these interfaces instead, then traffic's going nowhere. It's going to null 0, which is effectively nowhere. that is how you could do it. And let's have a look at how we configure this. Okay, so we're going to go back in here and we're going to go to the same line in the route map. So route map RM1, and we're going to go to permit 10. We can leave the match statement, but we're going to add another set statement. So set tag, and I'm going to choose the same number as the ACL to make it easy. So 199. And that's it. Now if I'll just do a do show route map, and we can see I now have two set clauses under that same sequence. So it's going to do both of these things. So right now, will that change anything? Well, I wouldn't anticipate anything to change. If we go to router 9, it still works. No issue there. Why does it still work? Well, because we haven't done anything with this tag. Remember, we have to associate it with those interfaces. So what we're going to do is we're going to associate this route map with those interfaces, and we have to now do something with that tag. And that's going to involve the next sequence in this same route map. So if I go to route map, I go RM1, permit on sequence 20 this time, I'm going to match, and if you do a question mark, you'll see there's many things you can match, not just IP addresses. One of the options is tag. So I'm going to match the tag of 199. And so as long as the traffic has been tagged with 199, now I'm going to set the exit interface to null 0. Okay. So are we done yet? Not quite. Still got to associate it. Now, you might be asking yourself, how do I associate just that one sequence with an interface? How do I associate both of these interfaces with just this sequence here? Well, that's not what you need to do. That's not how route maps work. Remember, route maps go through things sequentially and check the sequences one by one. And so we're actually just going to associate it with the same route map, and the route map will be checked when traffic is leaving, and what will happen is hopefully it's going to evaluate sequence 20 because it's going to match this and therefore set this. Alright, so we can see it's got 0 packets that have been evaluated so far. And again, if I telnet on router 9 and now go back to router 1, we refresh that, we see that this hasn't increased at all, but this went from 74 to 92 packets. So it's still evaluating on that first sequence. Second sequence is not being used. So now, I'm just going to check what these interfaces are on R1, Ethernet 00 and Ethernet 01. Now I'm going to go to interface Ethernet 00 to 1. This is going to, interface range. So now I'm in both of them just to make it a little bit easier. And now I'm going to do IP policy route map RM1. Done. Okay. So noting that this interface is still down on R1, what do we think is going to happen when I try to telnet through an R9 now? What do we think is going to happen? Let's see. Hopefully you come up with an answer. It's trying. Noticing before it was working instantly, and now we've got a connection timeout, remote host not responding. Let's try again. Trying. It's trying, and no dice. Sorry, mate. Let's have a look at the route map. So we can see that we now have 4 packets that have been evaluated by sequence 20. So 4 packets that have matched and therefore have been set to interface null 0. So it would have been 2 packets per attempt. Let's just double check that, I'll go back to router 9, run it again. It's going to try for a few seconds and then it's going to time out and fail. There we go. Let's recheck. Yep, it went up by 2. Also, noting that the first sequence has gone up by 2. Now, why is that going up by 2 as well? Well, that's because this has been performed, this has matched as it's entered router 1 through serial interface serial 2/0, and then the second sequence has matched as it's tried to leave either interface Ethernet 00 or interface Ethernet 01. So we have now effectively, using route maps, manipulated traffic so that it'll only use this one next hop address. Not good practice. This is not best practice. You should be using just access control lists if that's what you want to achieve normally. Or there's other options available to you. Route maps are not the best option to achieve this goal. So let's just go into that last interface and bring it back online just to verify everything's working the way we want it to. Okay, so it's going to come back up. We'll just give it a little bit of time for the OSPF neighbor adjacencies to come back up. There we go. Hopefully everything is working again. So if I go out of this and we do a show route map, we'll just double check. We've got 98 packets on the first sequence and 6 packets on the second one. Now if I try to telnet, boom, prompted for username again. And I'm back into router 5. Excellent. Now if I go to router 1, we double check. This has had plenty of more packets go through it in the first sequence, but we look at sequence 20, it was previously on 6, it's still on 6. So what happened when it came through router 1 is it went through that interface, it matched this, so because that interface has this route map associated with it, it checks, starting at the first sequence, it found that it does match telnet traffic as per the access list here. It set the tag to 199 on the traffic and the next hop to this address. So it doesn't matter that it set the tag to 199 because the device isn't looking on this exit interface on Ethernet 0/2 for that tag. There is no route map configured on that interface. It doesn't care for it. So the tag is there on the traffic, but the device just goes, okay, I see the tag there, and just sends it on. The next device, router 4, will receive the traffic, see it's got a tag, but it hasn't been told to do anything with that tag either, so it just sends it on, treats it like normal. That's why this sequence hasn't been evaluated, because we have not associated this route map with this final interface. So hopefully you've learned a fair bit about route maps and their strengths and weaknesses. So they all fall under policy-based routing, and it's meant to be used to manipulate the way that we utilize traffic connections, especially in this like redundant sense. But the biggest and most common use for these route maps is when it comes to distributing between different routing protocols, and also just between like intra areas as well. So we've covered off the first part of the use of route maps, and now we'll follow with a little bit more detail into how we can use route maps with routing protocols. People that want to learn a little bit extra and get a little bit more in depth into the route maps, I've got some bonus material to cover off on. And some people, some real eagle-eyed viewers, may have noticed that there's potentially an easier way to do this. But let's just see if we're both thinking about the same thing. So you might be asking yourself, why bother with this tagging and sending it to a null interface and everything when you could just do a route map rm1 deny instead of permit? Wouldn't that just achieve exactly what you wanted? You won't have to bother with this sending it out interface null 0 if you just change it to a deny sequence instead, right? Surely. Well, let's see. Let's see what happens. So I go conf t. I love saying let's see. I love just going into an actual demonstration so you can actually see how everything works. Hopefully it's not too annoying when I say that. So route map rm1. We're going to go to permit 20, and we're actually going to just do no on the start, and that's going to remove that entire sequence. So if I do show a route map, you can see there's only sequence 10. So this time we're going to basically do the same thing. I'll just do up arrow here, and I'll get rid of the no on the start. So the same thing, route map rm1, but we're going to replace permit with deny on sequence 20. So we're going to deny on sequence 20. Let's match the same thing we had before. So match that tag of 199. So any traffic that has been tagged with 199 is going to be denied by this sequence. And that means we don't have to set anything, right? So if we do exit, done. Let's just do a do show of the route map. And we can see we have route map rm1 permit sequence 10, and then route map rm1 deny sequence 20. And it's matching this tag traffic. Now, you might be wondering, well, isn't that a concern? Isn't legitimate traffic now going to be denied? No, because a route map, if you remember from the theory lesson, is once it matches a particular sequence, it performs whatever it's been told to do, and then it breaks out. It doesn't do the next sequence. So as long as it matches, as long as it is genuine telnet traffic from that network, it sets the tag to 199 and the next hop, but it will not perform sequence 20. Because it has matched, it does that one sequence and then breaks out of the route map. If it doesn't match in this, then it moves on to sequence 20. Right, that's how it works. So now, if we think about what's going to happen, is when the traffic is trying to go, so we'll shut down this other interface. So shut down interface E02. So again, we're now going to be forced to go via R3 or R2 for that telnet traffic. But sorry, I'm just scrolling up a little bit. For the telnet traffic now going through R2 and R3, it's going to have the tag on the traffic already as it came in on the egress interface on S20. It's then going to go to sequence 20, and it's going to have this deny sequence 20 for the traffic that's tagged to 199. Let's have a look what happens. So on router 9, I'm now going to telnet through to router 5. It works. It does not deny. Okay? So it doesn't just deny on its own. That is not how the route maps work. It will not. So you try not to think of that deny option in the route map as something that you can use here, because when you're associating it with the interfaces like we're doing in this example, that's not how the route map operates. You can use that deny function more when you go into using route maps with routing protocols, but as we're associating it with interfaces, it doesn't behave that way. So I'll just do a double check of the route map, and we can see it has not evaluated that sequence at all. Okay, so it has not actually run through that sequence at all. Even if we add in this set clause, let's have a look. So we go to route map rm1, we go to deny 20, so we're in the same sequence. And now let's do a set the exit interface, let's get rid of that, interface to null 0. So now we basically have the exact same thing we had previously, except we have the word deny instead of permit here. So the same thing we had before, we're matching, setting it to null 0. It's still associated with interfaces E00 and 01, route map 1 that is. But let's have a look. Is it going to do the same thing? Telnet? No, Telnet still works. And if I refresh this, it hasn't matched. It's not matching. Let's just show you how it does work again. If I go to route map and use the same name, RM1, and I'm going to permit like we did before, and now I'm going to go to sequence 30 and just do the same thing. Match tag 199 and set interface to null 0. So what does it look like? Show route map. And now we can see we have sequence 10, which is permitting. We have sequence 20, which is deny, and sequence 30, which is permit. So sequence 30 and 20 are the exact same. They're matching on 199, and they're setting exit interface to null 0. But the first one, sequence 20, is deny, and the second one is permit. Okay, so let's have a look what happens when that match goes through the router. Of course, I was confused there for a second. So what it's doing is it's going through and hitting this sequence here, and as soon as it hits this deny, it's then breaking out of the route map. Right, so it's basically going through this deny sequence here, and that's it. It doesn't do anything. Once it hits that deny, it's gone, because this is the weird behavior of how the route maps work when you're associating the route map with an interface. So if I remove this sequence altogether, we should see a bit of better performance, because what's happening is it's hitting this, basically doing it or ignoring it, and then breaking out of the route map. So it's no longer going through to sequence 30, because it's essentially matched this deny, which it does nothing for. So if I go back into configure terminal, and let's do a no route map RM1 deny on sequence 20, and that should be it. So now we have a sequence 10 and a sequence 30, right as we had it before initially, except this is on sequence 30 now instead of 20. Now if we go back to router 9 and telnet, it's going to fail. Alright, connection timed out. Let's double check again. Allow it to time out once more. And then if we refresh this show route map, we are seeing it's now evaluating sequence 30 again. Okay, so before, if I scroll up a bit, when we had the 3 sequences, and we had sequence 10, 10, 20, and 30. Let me just move this so I can try and move the screen a little bit slower. Up a little bit. Okay. So it's sequence 10 and then 20 and 30. It was not getting through to this sequence when it was going through the first 2 interfaces, so Ethernet 00 and 01 router 1. It was only reaching this sequence 20 deny and then leaving. It was not performing anything at all, which basically means that the traffic is allowed through. So it's quite confusing and can be very hard to wrap your head around, but that is why you don't use route maps for this sort of route manipulation, not route manipulation, but traffic manipulation. That's not the purpose for them. Okay, so this bonus material, it's a little bit more complicated, but if you now fully understand it, you now understand some of the limitations of route maps and why you wouldn't use them for this sort of network behavior. Okay, hopefully you've learned a lot, and I will see you in the next one.